Hello everyone, welcome to Homeschooling channel. Today we are going to cover part 2 of Circle chapter. If you haven't watched part 1 of Circle, I would request you to go and watch part 1 first, then come to this video. In this video, first we are going to cover some basics first, then we will take some questions after that. So let's go. So now we are going to learn few more properties of circle. So what is a tangent? Tangent to a circle is a line that intersect the circle at one point. So this is a circle, a line that intersect circle at one point. If it intersect at one point, then it is called as tangent. But if a line passing through a circle and it intersect at 2 points, like here in tangent only point A, and here in this figure we have where the line is intersecting at 2 points, then it is called as secant. So 2 point A and B, that the line PQ and the circle have, in this case we call the PQ a secant. So if the point of contact is 1 by a line on the circle, it is called as tangent. If there are 2 points of contact, A and B, 2 points, then it is called as secant. Now the length of the tangent, see, tangents can be, this is a tangent, so tangent can be drawn like this also, like this also, sorry, this only 1 point, here also only 1 point. If it is passing through 2 points like this and this is going to be called as secant. So the length of tangent drawn from an exterior point, let's take P as an exterior point, then the length of the tangent drawn from an exterior point to a circle. So this is an exterior point, and if two tangents are drawn, PQ and P, then both the tangents will be equal. Hence, so PQ and PQ is equal to PR. So both these tangents will be equal. A tangent is also perpendicular to the radius. So this is your tangent PQ and this is your radius OQ. So the angle would be 90° here. It is perpendicular. PQ is perpendicular to OQ. Similarly for this tangent PR, this is the radius. So it both of them are perpendicular to each other. So this is also going to be 90°. Now let's see here that uh, what we have read here is that angle Q, because PQ is a tangent, then it is perpendicular to the radius, so the angle would be from 90°. Similarly for this one also, the angle would be 90°. So if you see that PQOR is forming a quadrilateral, so the total angle of quadrilateral is 360°, and we already know that these two angles are 90°. So the remaining two angles would be 180°, because the total sum is 360°. So these two angles, their sum would be 180°. Now area of segment. Before segment, you need to understand what is a sector. See, if this is your circle, this is your center O, and if we extend two lines along the radius like this, then the area within, then the smaller area within would be called as the minor sector, and this larger area, it is called as major sector. Now let's say if the angle of this is 360°, of this sector is 60°. So as we know, the whole angle would be 360°, so the angle of major sector would be 360 minus 60, so it would be 300°. So this is your minor and major sector and their angles. If the angle is of a minor sector is 60°, then the major sector would be 360 minus the angle of minor sector, that is 300 degree. Now similarly, if two lines are drawn, then the smaller area is called as minor segment and the larger area is called a major segment. And if we take two lines from here to here, okay, like this, if now area of, if we have to find the area of minor segment, then the area, first we have to find the area of corresponding sector, that is OAPB, this sector OAPB, and the area of corresponding triangle, subtracting the area of corresponding triangle, so triangle OAB. So if you have to find the area of the segment in a circle, then we have to draw these two lines. The first we have to find the whole sector area of the sector OAPB, this is your minor sector, and from that we have to subtract this area of triangle OAB. Now let's come to the formulas. Let's take this one as an example. Okay, this is your center, this is your radius, there are two lines, and the area within, this is your minor sector, this whole shaded blue area is minor sector, and the angle extended by it is theta. So if we have to find the length of the arc, that is APB, length of the arc APB, then the formula would be theta by 360 degree and into 2 pi r. Okay, similarly, if we have to find the area of the sector, its whole blue shaded area of the sector, then the formula would be theta by 360 into pi r square. So these two formulas are very important. You have to remember both the formulas. Now there's one more way to remember this formula. See, theta by 360 is common, so length of arc, as we can see, it is going across the circumference, so the angle of, sorry, the circumference of circle is 2 pi r. So length of arc, for that the formula would be 2 pi r. Here pi by 360 is common here in both the formula, but here we are finding area, so area of circle is pi r square. So this is the way, this is one way by which you can remember both the formula theta by 360 and what is the circumference of the circle, and theta by 360 into area of the circle. Now sometime in question the angle is given either in radian or in degree. If it is given in degree, you can use both these formulas to find area and length of the arc, both. But if it is given in radian, it is given in radian, then you have to convert radian into degree. So let's say for that the formula is radian to degree is radian into 180 degree by theta. Let's say radian given is 8 pi. So what is going to be in degree? 8 pi into 180 by pi. So the angle would be 180 into 8. Similarly, if you want to convert from degrees to radian, then the formula would be degree into pi by 180 degree. So you have to remember these four formulas: length of the arc, that is theta by 360 into circumference, which is 2 pi r, area of sector is theta by 360 into area of circle. And if the angle is given in radian, and there's one way to find the angle is given in radian, that it will always consist pi. So radian to degree, so we have to write radian into 180 degree by pi. Similarly, degree to radian, degree into pi by 180 degree. So all these four formulas you have to remember properly to solve questions in examination. Now let's move on to the questions now. So this is our first question. A tangent PQ at a point P of a circle of a radius 5 centimeter. So let's take a circle here. This is our center. Now what we have, tangent PQ, if and tangent PQ at a point P on the circle. So there would be a point P and another point Q. So PQ, as in question it is mentioned point P of circle, so it would be here, and the radius here would be 5 centimeter through the. So a tangent PQ at a point P of a circle of radius 5 meets a line through the center O. So this is your center, and if this line would be equal to OP, would be equal to radius, which is equal to 5 centimeter. Here it is given that meet uh, so meets at a line through the center O at a point Q, so that OQ is 12. So OQ is 12, and as we have read that if a tangent intersect the angle between the radius and the tangent is always 90 degree. Both the lines are perpendicular to each other. So from this, by using Pythagoras theorem, we can say that OQ square is equal to OP square plus PQ square. So PQ would be under root OQ square minus OP square. So OQ is 12, square would be 144, and OP would be 25. So form 9, 1 and 1. So under root 119. So this is going to be your answer. Now next question. In the figure, if TP and TQ are, so TP, this is a tangent, and TQ, this is also a tangent with tangent to a circle with center. So as we know that radius and tangent are perpendicular to each other, so this angle and this angle both would be 90 degree. Okay, center with, so that angle POQ is 110 degree. So POQ is 110 degree. So this is 90 degree, this is 90 degree, this is 110 degree, and we know that in a sum of all angles in a quadrilateral is 360 degree. So angle PTQ is going to be 360 minus 110 plus 90 plus 90. So the final is equal to 360 minus 290. So 360 minus 290 would be 70 degree. So this is going to be 70 degree. PT is 70 degree. So this is your answer. Now moving to the next question. If tangent PA PB from a point P to a circle. Tangent PA PB. Okay, let's draw a circle first. This is our center O to a circle. This is going to be a point, and it meets from here to here at PA and PB. This is going, this part is will be from here, like here, this. Okay, P. So this is P. Let's take this one as point A and this point as B. Line to each other to form an angle at 80 degree. So the angle would be, if tangent PA PB from a point P to a circle with center O, okay, ठीक है, are inclined to each other. These two are inclined to each other at an angle 80 degree. Okay, so we have to find what is the angle POA. So we have to draw a line here. So we have to find this angle. What is going to be this angle? So as we know, these two angles would be 90 degree, and these two angle also going to be 90 degree. Now as we know that these two are radius, so angle opposite to the to the equal side would be same. So this angle and this angle would be same, so both the angles would be 40 and 40. This is 80 degrees, so this both of them would be 40 and 40. Similarly, we have read in the properties that if a point P is there, and if two tangents are going from that point, then both the length PA and PB will be same. So if PA and PB will be same, so these two angles will be also same. So let's see, we know that as we know that angle B is 90 degree and angle A is also 90 degree. Okay, these two angles, this angle and this angle, and angle APB, this one is 80 degree. So we know this is a quadrilateral, so total angle would be 360 minus 80 plus 90 plus 90, so it is 180, 260. So 360 minus 260 equal to 100. And we as we know that these two PA and PB are equal, as from this, as we know the property of a circle, both, so the opposite angle would be also equal, so these two angles are equal. So if this one is x, then this is also x, so 2x is 100, so x would be 50 degree. So hence angle POA, so this angle POA, this angle is equal to x, which is equal to 50 degree. So your answer would be 50 degree. Now moving to the next question. Two concentric circle of radius 5 and 3 centimeters. So this is our smaller radius circle and this is a bigger radius circle of 5 centimeter. Find the length of the chord of the larger circle. So we have a chord here on the larger circle which touches the smaller circle. So if we a line here, a chord here, it will not, so we have to put a chord here which touches here. So this is our this is our center O, 3 centimeter, and this is a 5 centimeter. So find the so we have to find, let's say this is AB, So we have to find the length of AB. So what we're gonna do is we will draw a perpendicular line, a perpendicular from O, and let's take this point as P. Okay, and join these two also intersecting at smaller circle. So this OP is going to be 3 centimeter, and OB, so this can also be the radius. So OB is the radius of larger circle, which is 5 centimeter. So now we have to find PB. So by using Pythagoras theorem, we can find PB is equal to under root 25 minus 3 5 square minus 3 square. So it is going to be 16. So PB is equal to 4. If this is 4 and this is a perpendicular bisector, so PB is equal to PA. So AB would be a AP plus PB. 4 plus 4, which is going equal to 8, and the final answer would be 8. Now moving to the next question here. The circle in the figure above has center O. Okay, this is your center, and the radius is 10. Okay, the radius is 10. If BC is perpendicular, this is perpendicular, so it is a 90 degree to AD. AD. Okay, BD is perpendicular. So here we are going to join OB. Okay, as we know, OB can also be the radius. As you can see, it is going from center to the to the to the to the circle, to the circumference of the circle. So this is our radius, and from the question, radius is 10 centimeter. So OB is 10. Okay, and from this also we can say that OA is also 10. So this is 10, this is 10, because OA is also the radius. So this is 10, this is 10. So if one angle is 30 degree, so we know that if two sides are equal, then their opposite angles are also equal. So this would be 30 degree. And in triangle, we know that sum of all angles would be 180 degree. So angle AOB would be 180 degree minus these two angles, minus 30 plus 30, 60. So 180 minus 60, 120 degree. So this angle is 120 degree. So this is a linear pair, so sum of the linear angles would be 180 degree. So if this is 120, so this is going to be 60 degree. Okay, so angle BOC is 60 degree, because this is a linear pair. So we have read in lines that uh, this angle would be 180 degree. So 120 is we have found it before, so the remaining angle BOC would be 60 degree. And if we take in this triangle, in triangle BOC, we already know this angle, this is a perpendicular, so it is 90 degree. So 90 plus 60, 150 degree. So what is going to be this one? 150. So total angle is 180 degree, so this is also going to be 30 degree. So now we know this is 30 degree, this is 60 degree, and this is 90 degree. Now in triangle, if you have read right triangles and trigonometry, there is a formula for we know this one, and we need to find OC. So we can write cos theta is equal to hypotenuse by base by hypotenuse. So cos 60 degree, base is OC, so you'll keep OC here, and hypotenuse is 10. So cos 60 is 1 by 2, OC 10. So OC is equal to 10 by 2, which is equal to 5. So we have to find the length of AC. So AC, so this is 10, this is 5. So AC is equal to AO plus OC. So 10 plus 5, hence the length would be 15. This is your answer. Now let's move to the next question here. So in the figure above, the measure of angle AOB is 5 pi by 12 radian. So the theta is given in radian. So first we have to convert theta from radian to degree. So for that we have to 5 pi by 12 into 180 by pi. So if you want to find degree, if you want to find angle in, so 5 pi goes here, pi goes here. Then if we calculate it, let's see what is going to be. Theta is going to be, after calculating, is going to be 75 degree in the calculator. So the theta in degree is 75 degree. Now length of the arc, as we length of arc AB, as we know, theta by 360 into arc. So 2 pi, arc is along the circumference, so we have to find this length. So 2 pi r, so it is going to be 75 by 360 into 2 pi, and the radius is 36 times 10. Let me solve this on calculator. It is 15 pi. Now this is going to be your answer. Now find the area of the sector. So area, we have to find the whole area, which is equal to theta by 360 into area of circle, which is equal to pi r square. So 75 by 360 into pi and 36 square. Let me calculate it on the calculator. So it is going to be 270 pi. So your answer would be this one. Now next question. The circle above with center O, okay, this is your center O, has an area of 36 pi. What is the length of major arc ABC? So we have to find this one. So first we need to find area of circle is pi r square. So 36 pi, it is given in the question 36 pi and pi r square, pi cancel, So 36 is equal to r square, so r is equal to under root 36, 6. So the radius is 6. So now we have to find this one, this arc, major arc. So length of major arc, so as we know this is 90 degree here, so the remaining would be is central angle, so 360 degree, so this is going to be 360 minus 90, 270 degree. So length theta by 360 into 2 pi r, so angle is 270 by 360 into 2 pi r is 6, so this will 3 times 4 times, if it 9 threes are 93, 19 to 3 times 19 to 4 times, now it will go 2 times, go 3 times. The answer is 9 pi. Okay, so this is going to be option C is going to be your answer. Now a horse is tied to a peg at one corner of a square. So if it is tied here, okay, so horse can only move from here to here, and the peg on one corner of the square shaped grass field of 15, so 15 and 15, both the sides are 15. Horse is tied to a peg at one corner of a square shaped grass field of side 15 meter by a mean of 5-meter rope. So this is your 5-meter rope. So if horse can go from this area to this area, so this would be 5-meter, this is going to be 5-meter. So your figure would be somewhat like this, 5 and 5, and this is going to be your sector, and here it is a square, so angle would be 90 degree. So area of sector would be theta by 360 into pi r square. So angle is, this one is 90 degree, so 90, 360, and pi r, the radius is 5, because rope is 5 and it can go from here to here, so r is 5 here, 5 square, so this will go 4 times, so this is equal to 25 by 4 pi. So this is going to be your answer for the area of the sector, so 25 by 4 pi. In part 2 of the question, the increase in the grazing area if the rope were 10 meter long. So instead of 5 meter, now we have 10 meters here. So simply theta by 360 into pi r square. So r is 10 and theta is 90 degree. So 4 times, so 100 by 4 pi, so 25 4 times, so your answer will be 25 pi. So if you increase the grazing area, if the length of the rope is increased to 10 meters instead of 5, then the area would be 25 pi. I would like to make a small correction here. In the second part of the question, it was asked the increase in grazing area. So if this one is 5 and if we take this one as a 10, this one as a 10, so we have to find the difference of what we have to find, what is the increase in grazing area. So we have to find what is this area. So for that, we for increase in grazing area would be this one minus this one. So it would be the larger pie, that is larger sector, that is 25 pi minus 25 by 4 pi. So if we take pi common here, take pi common here, 400 times minus 25, so it is going to be 75 by 4 pi. So that would be the increase in grazing area. So this is going to be your answer. Now let's move to the next question here. A car has two wipers, okay, which do not overlap. Each wiper has a blade of length 25 centimeters. So let's take this as a wiper, and it goes it like this, and this is your wiper here, and the angle that it forms is 115 degree, and the length of the blade, so this area that would be equal to the radius, this one is 25, and we have two of them like this. So now we can find the area. So first we need to find area of one wiper, then we can find, then we can do into two, then we can find the area of both the wipers. So first, area is equal to theta by 360 into pi r square. 115 by 360 pi r, so the length was 25 centimeter, so this is going to be the radius. As if this is a sector, then the length of the blade would be the radius. See, we can also see it like this also, then you would be able to understand in a better way. So 25 square. So let me solve this on a calculator. 150 divided by 360 into pi is 3.14, and 25 square is 625. So your answer would be 620 centimeter square. This is going to be area covered by one of the wiper, and we have to and there are two wipers, so the total area, no sorry, find the total area. Total area, so total area cleaned would be 620 this one is 620, sorry, it's not 626 centimeter. So 626 into 2 is equal to 1252 centimeter. So this is going to be your answer. Total area of both the wipers would be 1252. Now moving to the next question. So this is your a round table has 6 equal designs. So if we take a center like this here, so we can make something like this, and from here to here, similarly like this, it can be divided into 6 parts. So central angle is 360 degree, and it is divided into 6 parts. So 360 by 60 by 6 would be how much? So one angle would be central angle is 360, and it is divided into 6 parts. So 6 is going to each angle formed from the center would be, so now let's take this one. This is your center, this is your 60 degree, and this is your design. Okay, so both, so this is also radius, this is also radius, so these two angles are also similar. So this is 60 degree, and the remaining two angles would be 120 degree, and both are radius, so and the length, both are radius, so length of this side and this side will be equal, similar. So from that we can say that this angle and this angle would be equal, so 120 degree, so this and this, so 120 degree is there, so by divided by 2 it is going to be 60 degree each, so 60 degree here and 60 degree here, so this forms an equilateral triangle. So first here we need to find area of sector, area of sector OAP, this whole area. So theta by 360, so theta is 60 degree by 360, and area is pi r square. So radius here is given 28. If the radius is, find the cost of making the design, so we have to find the cost of this design that is made here. So this would be 1 by 6, so pi by 28 by 6. So the area of the sector, let me calculate it, it's going to be 410 centimeter square. Now if we have to find this one, the shaded area, then we have to subtract this triangle from the whole sector. So first we have to find what is the area of this triangle, and this is an equilateral triangle, so area of equilateral triangle OAB, equilateral triangle OAB is under root 3 4 by a square, under root 3 by 4, 28 square. Let me solve it on the calculator. So this is going to be 335. So design area would be area of sector minus area of triangle. So 410 minus 335, which is equal to 5 and carry 7, so 7. So the area of this one is this design area is 75, and we have 6 design areas like this one, 1 2 3 4 5 6. So total design area is equal to 6 into 75, 1 is going to be 450 total design area. Now we have to find the cost. So cost of design area is equal to 450 into $0.35. So if we calculate that, 157.5 dollars. So this is going to be a answer. Now let's move to the next question. In the figure above, circles are tangent circles are tangent each other, and the radii are in ratio of 1 is to 2. So if this is a circle, smaller circle, if we take this as a radius O, and this one is O dash, and we take this one as, so they are in the radii are in ratio 1 is to 2. If this is r, then this would be 2r. If sum of their area is 8 pi, so first we have sum of their area is 8 pi, what is the length of AB? So we have to find, so before the length of this line AB as a whole. So sum of area of both area is equal to area of smaller circle plus area of bigger circle. So pi r square, this is also going to be pi r square. Here the radius would be, as we know, r. Here it is given r for the smaller, so it is going to be r square only. Here radius is taken as 2r, so it is going to be 2r square. So pi r square plus pi 4r square, which is going to be pi into 5r square. Okay, and in question it is given the sum of their areas is 80 pi. Sum of both the areas is 80 pi. So pi cancelled on the both sides. 80 pi, 80 pi, and 80 pi, hence r square is 80 by 5. So r would be let's find out, equal to be 16. So r square is 16, so r would be under root 16 would be 4. So now we know that. So if now we have to find the area. So if this is radius, so this is also radius, so we can write it as r. And if this is the radius of bigger circle, which is 2r, so this will be also 2r. So AB is equal to r plus 2r plus 2r. So total 2 plus 2 plus 2 6r. So the value of r is 4, so 6 times 4 24. So length of AB is 24. So this is your answer. If you like the way I teach and want to buy a comprehensive course for SAT exam at a very affordable price, you can download our app from the App Store and start your self-paced preparation from pre-recorded videos provided in the course. My course also includes chapter-wise practice questions along with 20 test series at par with SAT exam. You can find all the links in the description below.